Alright, I'm going to use an example very close to one we had before in an earlier video to try to help you feel a little more comfortable with solving things that just don't seem right at first. It just seems like it's got to be tougher than it really is. Now, we have this equation. It's got an x squared and it's got an x. Okay, and that's the first thing you got to recognize. X squared and x, great. I can't add those together. They're not like terms, so my old algebra techniques are not going to work here. So the first thing I should think of is factoring. But in order to factor stuff, I need to move it all to one side. So I need that negative 7x to come over here. And then I've got to set everything equal to 0, because that's sort of the strategy we've employed. Now I know there's this 3 out here, and that immediately is going to bother some people. Just go with your process. You don't have to see where this is headed all the time. You just trust your instincts, trust the process, and see where it gets you in the very end. Okay, so let's do this. If I'm going to move the 7x over, I'm going to do the opposite. I'm going to add 7x. But keep in mind, I can't put the 7x with the 2, and I can't put it with the 3x squared. It's not like terms. So what I have to do is write this whole thing out. Okay? On one side I have equals 0. On the other side I have 3x squared plus 7x plus 2. Okay? I'm not going to put anything together because they're not like terms. But what I can do now is factor and try and make each little piece, each quantity that I don't know, equal 0. By the way, in case we haven't mentioned this before, when you see an x squared, that usually means there's a good possibility you're going to have two answers to that equation. You've got to find both of them. Now, 3x squared, plus 7x plus 2, we already factored this in an earlier problem. 3x times x, 1 times 2, both are positive, and that right there would FOIL back out to give me the 7x. Remember, I have the 3x times the 2 gives me 6x, that gives me the 1x, and now I get 7x from my middle term. Okay, so I'm going to erase that out of the way here. I'm going to remind you of what we've done before. Now we take each term, or not each term, each quantity that we don't know, and we try to make it equal 0, because if one of those quantities is 0, the whole thing equals 0, and it's a true statement. So I'm going to write x plus 2 equals 0, and I'm thinking to myself, what number can I put in for x that makes this happen? Well, if I subtract 2 over to the other side, I get x equals negative 2. Okay, that's the easy answer to come up with. That's one of them, and that's correct, but we're only halfway there. What about the tougher one? This is the part that bothers people a lot, because it's one they look at and say, I'm not sure if I can do that in my head. It's not a nice whole number, and so they assume it's wrong. An answer does not have to be a whole number to be correct. In fact, there's an infinite amount of numbers that are not whole numbers, and it doesn't make them more right or more wrong. You just go with what's accurate. So I'm going to take this value and say, you know what? Just like I did in the purple, I need to make that equal 0. I need to know what x value makes that quantity 0. So instead of trying to do it in my head, I'm just going to write out 3x plus 1. I want that to equal 0. What x value is going to make it happen? Well, solve this. Pretend this is just an equation you had back in the first semester. Subtract 1. So I get 3x equals negative 1. Divide by 3. Divide by 3. X equals negative 1/3. And that's my other answer. And it's okay to have answers that are not whole numbers. This original equation has two possibilities that both make this a true statement. X equals negative 2 or negative 1/3.